Hello. In this example, we want to work with interval notation. Now, interval notation is, interval notation is just one of three different ways of representing solutions to inequalities. So a set of numbers on the number line can be noted in three different ways. So the first one is set builder notation. The second one is the number line. And the last one is the interval notation. Now, here's the thing. These curly brackets that you see here are all used for set builder notation. And this is important to understand because set builder notation is actually very useful. But it's hard to read sometimes if you don't know how to read it. So these curly brackets are, first of all, they're curly brackets. They're not squiggles. They're not threes and stuff like that. It doesn't work like that. It doesn't work like that. It's not a 3 and a backwards 3, anything like that. It is basically that. Oops, sorry. It is that, kind of a S, and then the backwards S. There you go. That's a curly bracket. Now, the reason I mention that is because people tend to not even try on these, so please at least try to create these. But let's talk about how we read set builder notation. So this first curly bracket means the set. And then whatever's right there in this case means of all x values. And then the vertical line there just means such that. Okay, so for this first set builder notation, we have the set of all x values such that x is greater than a. And that's pretty much it. And with this information, that tells me that we're just having all of the numbers of x that are greater than a. That's pretty much all it is. So if we look at this, the number line for this representation would look like this. Basically, we just want to look at x is greater than a. So in this case, that means that a is somewhere here in the middle, and we're going to the right of a. Well, sorry. There you go. You can kind of see it by thinking of that as an arrow pointing to the right. So this would be everything to the right of a. So taking a, we're actually going to shade everything to the left, or excuse me, everything to the right of a, including that arrow. But notice that this is just greater than a. It's not greater than or equal to a. If it was greater than or equal to a, we would include a. But here, a is not greater than a. So I cannot include a. So here's how we denote non-inclusion, or in other words, exclusion. We use a parentheses. And in this case, it's a parentheses opening to the right. And so here, that means that parentheses means we exclude. And in order to show if we would ever include, that's a square bracket. Okay. Now on the number line, remember the arrow to the left is negative infinity, and the arrow to the right is positive infinity. And remember that with both negative infinity and positive infinity, we're always going to use parentheses, either parentheses opening to the left or opening to the right, whichever way. So that's for interval notation though. This is the number line for the set of all x such that x is greater than a. Now for the interval notation, here's what we're going to do. We're going to start with the number line and say, where's the very first thing from the left that we can use? Well, it's at a. So it starts at a and goes comma, how far to the right can it go? Well, it'll go to infinity. Okay, so with the a, notice that we used parentheses, so we have to use a parentheses over here for the interval notation. That denotes that we are excluding it. And again, with infinity, or negative infinity, depending on which one, we always use parentheses. And the reason that we don't include infinity is because infinity is just a number. The infinity is just an idea. It's not a real number. So infinity is the largest number you can ever think of, plus one more. And then just from that one, plus one more again. So you're never actually going to reach infinity. Excellent. So for the next one, we have the set of all x such that x is less than or equal to b. Notice that that's less than or equal to there. So here we're going to start out with the b in the middle and go to the left. So start with the b and shade everything to the left of the b, including that arrow. Now notice that this is less than or equal to. That or equal to means we need to actually include the b into the set, so we need to go ahead and make sure we use a square bracket there, opening, of course, to the left. Excellent. That is the number line. Now let's go ahead and draw the interval notation. Now with the interval notation, remember the arrow to the left is negative infinity. So the very first thing we can use is negative infinity, comma, what's the very last thing to the right that we can use? Well, that's b. So make sure you use parentheses with any infinity being negative or positive infinity. And then in this case, we're actually going to use a square bracket for b. Excellent. Now for the last one, the set of all x such that a is less than x is less than or equal to b. Well, here's the thing. A is less than x is less than or equal to b. That's actually what we call a compound inequality. There we go. Since that's a compound inequality, it's called that because it's technically two different inequalities. What this means is actually a is less than x and x is less than or equal to b. Well, with a is less than x, that actually means x is greater than a. And then we also have and x is less than or equal to b. Well, we're also being told that a is less than b here. So it means that a is to the left of b. Now, let's think about this. Don't write this part down. X is greater than a means we start at a and go to the right. X is less than or equal to b means we start at b and go to the left. And this and means that both of them have to be true at the same time. In other words, we want the overlap between these two. And the place where both of these are overlapping is between a and b. So that means that a is less than x is less than or equal to b is everything between a and b. As for our endpoints here, for a, we had a less than, so a less than symbol is simply parentheses. And for b, we had a less than or equal to, and that is a square bracket. Remember, just a less than or greater than is parentheses. Less than or equal to, greater than or equal to is square bracket. So less than or greater than. And technically not equal to as well for the exclude. For the include would be less than or equal to or greater than or equal to. And the equal would just be something else entirely. Okay, so a to the left, b to the right means that for our interval notation we have a, comma b. The a was excluded, the b was included. And that's pretty much it. Alrighty, well, now we know how to use interval notation, and we're doing that in order to be able to write down the solutions to linear inequalities. And now that we know this, we can go ahead and start solving linear inequalities. That means I'll see you in the next example. Have fun.